Amazon Stage.
Hi, my name is Maciek, and I would like to welcome you to another episode of Amazon Stage, the podcast about technologies that change the world, seen through the lens of people who are actually building those technologies. My guest today is Edward Guo, Science Director in Amazon's Alexa AI organization. Edward previously led engineering and science teams at Microsoft and has spent over 8 years at Amazon building the science behind Alexa, from self-learning systems to the personalization agent powering Alexa Plus. Most recently, Edward has been leading the effort to build the runtime architecture, Alexa Foundation models, and inference engine that powered the launch of Alexa Plus, Amazon's next-generation AI assistant. He has also co-authored research on personalization and user modeling, self-learning system, LLM-based agentic systems, and NLP systems deployed at massive scales. Edward, welcome to Amazon Stage. Thank you so much for being here, and tell us what brings you to Poland.
This is my first time to Poland, and I come here to thank the two teams that I have here, making huge contribution to the Alexa Plus launch.
Cool, awesome. Well, great to have you, and I'm so happy that we can have a conversation today.
Thank you.
So before we dive in, our traditional question here in those episodes is, what do you usually have for breakfast?
I usually have breakfast on I usually put a piece of bread over there and a Swiss cheese on top of it in the microwave oven for 30 seconds. And when the cheese melts, and that's my favorite breakfast I always have it because it's easy to make.
All right, that's a very specific prescription on how to.
Yeah.
Okay, that's very nice. Cool. So I wanted to. So you're obviously today, a science director at Amazon, and we'll get to that. But before we get to that, I wanted to ask you how that journey started for you, right? So you studied computer engineering at Carnegie Mellon, and your research background spans information retrieval, NLP, deep learning, image processing, like very, very broad range, right? Mm-hmm. Was there a thread connecting all that? And have you been interested as a child on these topics? How did that sort of happen for you?
My research actually starting from Fudan University, very beginning in China, Shanghai, and my research is focusing on image processing. Mm-hmm. When I go to Carnegie Mellon, and I studied MEG signals, which we basically extract the brain signals and trying to understand how we understand brain signals. Mm-hmm. You can imagine these are understanding how the information flow into how the perception of these informations. Then I go to the Microsoft. I joined the Bing search engines, and then the journey is starting my research interest into information retrievals, NLPs, and all these things become understanding users' intent on that. And then I goes to Amazon, of course, Alexa, and Alexa is not just perceive what user said, understand the intent, also taking actions.
Sure.
Then my research becomes the AI-based research. So if you can see, it's about 3 stages. First of all, understand the users, and then understand the user intent, and then take actions.
Got it.
That's the thread that I'm following.
Interesting. So before we go to Alexa, you've been, at Microsoft, you've been working as a principal engineer, right? Can you tell us more? Have you been consciously walking into the individual contributor role, or did that just happen to you?
I started with IC roles in the individual contributors, mm-hmm. and to the point that I feel I need to make a big impact. I need a team. So that's why converting me into become a manager and I can have more ideas to do.
Right.
So that's the main motivation for that.
Got it. And then you joined Amazon and you joined Alexa first, right? Or originally you joined Alexa in Amazon. What did drew you to that team effectively?
What drove me to that team is when the first time I heard about Alexas, and I realized Alexa is actually not learning from customer data. So I think in Microsoft, what I'm doing is the search engine. We all know that in search engines, and we use customer feedback data to improve the qualities. And there's a click-through rate for what user click, and eventually you can improve in the search engine. But Alexa happens to only relying on user reporting the issues and human annotations to find the issues. That means we leave many customer problems unattended. So I believe in my expertise and at the search engine can help transforming Alexa to be self-learning. So that's where drew me into the Alexa assistants to improving Alexa, so allow Alexa to learn from the customer. And I do believe in this. At that time, I was probably the only person who has that expertise over there. That's drew me into Amazon.
Wow. So you came in actually with an idea how you can make Alexa better effectively.
Yes.
That's super, super interesting. And so now currently you're a science director, right? And I guess maybe our viewers and listeners would wonder, like, okay, so what do you actually do every day? What is that you're actually doing?
Yeah. I'm a science director, but actually I also have an engineering team building the runtime systems. If you think of my days, my day always starting to help like scientists, engineers to coordinate in order to shipping the product. That will be the beginning of the days, and help our partner teams to build this product at scale and empower them more. And later of the days, I would say we're spending the time like auditing the projects in science engineering, help people making decisions on architecture, like debates over there, and resolve these debates. And then I was spending some time maybe on research and look at papers, because I need to make sure my knowledge is always up to date. And my team is the innovation center for Alexa, so I have to guiding Alexa in the right innovations directions. That's what I'm doing.
Got it. So if I would need to create like a block of this, it sounds like the first block is effectively unblocking teams who need to deliver and ship stuff. Second block is really design and architecture discussions, right?
Yes.
And then third thing is learning. And then do you also like co-author research papers, right? Science papers. That's also that block, right?
Yes. Yeah. I co-author many papers. I guiding the team research a lot in the ways like a lot of ideas. I work with the scientists, work with the interns all together. Of course, my time is limited, but I always try to reserve certain times for this.
How do you manage that? Because I imagine that like keeping the balance between the like, oh, we need to solve that issue now, and then thinking about forward-looking innovations, right?
Yeah.
I assume keeping that balance is quite hard. How do you handle that?
Yes, it's indeed very difficulty, and sometimes, but I think it's more about the discipline. Just like you do exercise every day, if you keep that exercise all the time, you're always going to find 5-10 minutes, even to be more efficient doing that. So it's really make sure you have that discipline at yourself to do it. Of course, whatever the most urgent things for the company goes first, and it could be having one day you just don't get time, but you always make up for that exercise.
Got it.
Yeah.
So effectively, you do make decisions on the spot, but you are still trying to spend at least some amount of time on one of those three blocks.
Exactly. Especially if you look at these days, like in the LM world, things happening so fast, even happening in hours, and there are exciting news coming out of that, and you have to learn every day in order to make sure the Alexa sense direction is not being obsolete.
Got it. So you mentioned Alexa, and I want to dive deeper into that, right? So Alexa was released, I believe, in November 2014. I have been here for that. And so if there is a customer who only knows that original Alexa, right? That one which was with us for many years, right? Before Alexa Plus. How would you explain to that customer what Alexa Plus actually is and what it brings?
I think if you look at the older Alexa, we feel older Alexa is a command center. Now you basically have to say the exact Alexa sentence in order to get that functionality.
Right.
So sometimes we call Alexa speech. People need to say the Alexa language in order to get the command.
The particular exact query. Yes.
Now, I think the new Alexa, it's understanding your dialogues. So that means like you can really understand your context, your who you are and what situation you are in, all this information, and was able to make the right decision for you. So you don't have to follow particular utterances or what you need to say the command in order to make Alexa work. You actually can feel free to have a conversation with Alexa in multiple rounds, and it will do the right job for you.
Got it. And so effectively, I guess how you can summarize that, you went from like a very structured, rigid framework for the interaction to like a very unstructured, ambiguous framework.
Right.
And we still are able to understand. So Alexa is able to understand and execute upon the user intent. Is that right?
That's right. You can think about what goes from pattern matching become a dialogue understanding part.
Got it. And for somebody, like some people might imagine, okay, good. Any LLM can do that today, right? Did you just, turn on an LLM model behind Alexa and that's it? That's Alexa Plus?
I don't think so. I don't think you can make Alexa Plus just turn on the LLM model. Otherwise, you will already see many Alexas, Alexa-like engines like everywhere. I think Alexa Plus, there's a lot of things make Alexa Plus feasible. And first of all, Alexa is really a many years product, has a lot of details there. We cannot just switch the brain completely. And goes a little bit in my team's areas, like we all know, like today, in order to ship a product, you need to be very careful about the latencies. And so we know LLM models, they are slow.
Yes.
But Alexa needs to respond in sub-second or response within 3 seconds for a lot of requests over there. Normal LLM cannot do that. State-of-art LLM is too slow. The second thing is the cost. We all know LLM is very expensive to run, and you can't really run every interaction on the best model for the world. The third thing is about accuracy, right? And Alexa, some of the Alexa actions need to be super accurate. For example, you want to set a timer, you don't want to get it wrong.
Right.
And these things we know will not get 100% right. So I think we have all these kind of challenges need to resolve in order to make a product. Of course, there's many other details over there, like in order to make Alexa as a product regarding how you respond to the user, what your personality you want to be. And these are all the effort needs to make Alexa Plus possible. It's not just about model. You can have the best model, but you will not have Alexa Plus as a product.
Got it. So before we go into that about what Alexa is, not only the model, I do want to ask a follow-up question on what you said, right? Like, maybe explain to somebody who doesn't think about that, like, why is latency actually important? So the fact that a customer can ask a like unstructured question and then has an expectation for Alexa to respond fast. Why is that?
I think it really depends on the expectation for the task you want to do, and especially for smart home. You don't want open the light become 10 seconds,
exactly
to happen.
That would be very frustrating.
Then user's reaction will probably just go to the switch and press the button, and he doesn't know if Alexa just goes some wrong state or it's actually because of the latency. So. But you could be right on certain kind of task, it will run a little bit longer. That's what you see Alexa today, some of the tasks, it will actually run longer just because of the complexity needed. But in general, want Alexa to be super fast for the task really needs to be sub-second response over there.
Got it. And you also mentioned that there are some types of the tasks which need to always lead to the very exact same finite result, right? So setting a timer, for example, right? Again, somebody could say, well, that should be super easy, right? Can you explain why this is not easy?
Yeah, I mean, if you think LLM model, it's a stochastic model. So it doesn't yield like determinisms over there. And that's why if you use LLM in this inference, that's become very difficult to achieving 100% accuracy. And I think that's one of the challenges we're trying to overcome in Alexa, in the systems. And I think some of the approaches was also trying to combine the traditional method that we have in Alexa, the original Alexa, and in order to achieve the high accuracies over there.
Got it. And so you mentioned, hey, Alexa is not just one model, right? So what is it? Is it like multiple different models? Is it multiple different models and business logic? How does it actually work?
Yeah, I think for Alexa, that's one of the biggest contribution in my teams. Like we introduce the model invariant architectures, meaning like we have Alexa built it behind has multiple models, and based on whatever the workload needed, we choose the best models for the task without sacrifice the accuracies. But lowest cost and faster speed.
Got it.
So we have our in-house model, which is much, much faster than the state-of-art models, but was able to achieve the same accuracies. But we also acknowledge we cannot do good for every traffic.
Got it.
Because there's complex tasks where these simple, small models cannot do it. Then we have to rely on the state-of-art model, which is in very large size, but very costly.
So effectively, if I would have to explain it to a customer who's using maybe one of the LLM applications out there, maybe Alexa.com, right? Is like, sometimes they're able to select that model, right? In the chat interface. I think what you're saying is Alexa is selecting that model based on the query, right?
Yes.
And it's able to select it in such a way that it adjusts best to the actual query.
Exactly. It's basically going to be based on the payload. And we know which is the best model to do that. And we're able to dynamically loading the right model for you.
Got it. So you also led before science teams working on personalization for Alexa in general, right? I wonder, what does personalization actually mean for a system which really has millions of users across different languages, cultures? How did you think about that back then?
I think personalization system needs to be able to scale, which means like you're able to learn from all different sources to profile the users. And in the runtime, you're able to apply these profiles on the runtime traffic to customize different response for these users. And this is what I believe in the definition of the personalizations for Alexa.
So effectively, to understand what that certain group of customers wants and prefers, and then serve that what they want to them effectively.
Yeah. But in personalization, we also think the personalization as individual users. And we're trying to build this in multiple layers. The layers of the things only very personalized to use, or we can identify the user cohort and doing the personalization, and that becomes infer some of the things you will like and help personalize the experience for you.
You mentioned how Alexa Plus needed to perform a very broad variety of tasks for the customer, right? So I think, it can also like book restaurants, right? Like control smart homes.
Yeah.
You can manage routines, right? That's all something that like not all the assistants out there can do, right?
Yeah.
So from a science perspective, right? What does that combination of those tasks, like how does it actually work?
I think if you look at the existing systems and the many systems, for example, if you use GPTs, you have explicit selecting what MCP servers that you want to connect it in order to do that. And if you have too many things selected, and I think the accuracy for the experience will go down. For Alexa, we do have routing systems in the top and trying to find out what's the most relevant MCP servers, and we call expert in the systems was able to manage our traffic. So with that system in the places, we're able to allow Alexa to discover a large range of the capabilities that needs to have for the interaction. So you can arbitrating across long dialogues with different abilities, was able to make the conversation continuous to fulfill users' request.
Got it. And so I assume it's such a hard task to crack, right? Because even from an evaluation data set perspective, like building an evaluation data set perspective, is probably a very challenging task, right?
Yeah, it's definitely going to be a challenging task because you can imagine humans' language is very ambiguous.
Right.
And if you want to make early binding decisions, and that's going to be likely to be a bad decision. Sometimes and different capability can serve the same utterance. That's what you just said.
Right.
So I think we are involving the systems and we'll be asking more questions to the users to clarify. Basically, it's very like the same way human communicates. Like you want to understand the intent. If it's unclear, asking questions before you're taking actions.
Got it. Yes.
Yeah. That's where Alexa is heading towards.
And I guess humans also take into account visual cues, right?
Exactly.
Which that's why I assume Alexa requires that multimodal capability, right?
Exactly. Multimodal is such an important element And we are now, at least for my daily life, I see even with search, I'm looking for something. In the past, I go to Google and just type in. Now I go to Gemini and others just like take a picture.
Right.
And
Right.
I think we are transforming the way how the information flows into our systems. And Alexa definitely needs to be in that place as well.
Right. So actually, maybe let's do, because I did sort of make an assumption here. Maybe let's explain what multimodality actually means for Alexa Plus.
Yeah, I think multimodality for Alexa Plus means two things. The first thing is understanding the input. So if you're talking to Alexa, Alexa knows that you are coming. It will recognize your face if you have the things enabled,
so there's
enabled.
The speech input and then the visual input,
which is coming the input
from the camera.
That's one thing. The other things I would say for multimodality features, and we also have the image generation. If you try the Alexa,
correct,
and you can ask Alexa to generate an image for you. That's a generation capabilities.
Right.
So there's twofold of capability for Alexa.
Got it. So Edward, your team also publishes research papers, right? But those papers also typically or must be also some type of capabilities or features for Alexa, right?
Yeah.
So can you tell us a little bit more how deployment then looks like? Is it that you first write the paper or first you build the feature? How does that work?
Yeah. Maybe first thing is, in order for us to be able to do research, right?
Yes.
You need to build infrastructure to supporting that.
Right.
So we build the infrastructure for model building. We call it CLDK, which is allow us, the scientists, to run experiments, build models. We also build evaluation framework. For example, the ARENA framework is basically trying to do side-by-side comparison of the experience. So we can do offline evaluations. And we also have online A/B testing framework, and basically allows the feature to testing on the user side. We call it Alter. And these are the three systems to supporting the innovations. So every time when we do the research or do the R&D on these things, we were starting from the offline model buildings, and we're trying to, in the offline, to validating this is the feature which actually works. And then the process, if it's being proven to be useful, then it goes to the online A/B testing and eventually shipping to the users. In that process, actually, the innovation happens in the parallel. Some of idea work, some idea doesn't work. For working ideas in parallel, we are writing papers or filing patents on the things we believe in it's worthy to contribute back to the academic or worthy to be as a business secret, how we make things happen.
Got it. So it's a very intertwined process, right?
Yeah.
So effectively, there is some feature or capability which we want to launch to our customers.
Yeah.
And then I guess you're at the same time building a hypothesis, right?
Yeah.
Which you're testing offline first. And then once you have like a working hypothesis, you might deploy it and then you test it with customers effectively, whether they like it or not.
Exactly. And the other things is when you're doing the publication and contribute back to the academic world. And usually we need to run more tests using the public benchmark.
Got it.
So that we can compare with if this methodology is better than the state of art ones.
Understood. And is that, generally speaking, important for you and your team?
It's generally important. I think this is important, first of all, for the innovation, knowing that we're not innovate something which people already innovated.
Got it.
Right? Don't invent the wheel.
Yes.
And secondly is it's important for us to also help academic world knowing what the industry problem that we are facing. Alexa is a large-scale voice assistant. A lot of problems the academic world, they may not pay attention to because they don't have that skill. So contribute to that actually help raise the attention to the problem, and people also can help to advance in the areas which, like a feedback loop, allow us to developing better algorithms or leverage other people's algorithms better than us.
Got it. So when you're building like an AI assistant for really millions of customers, right? I do assume you need to build for an enormous range of needs and abilities and ways of interacting with the actual technology, right?
Exactly.
Does that change the process, the science, behind when you need to build in that inclusivity from, an interaction perspective?
Yeah, I think, first of all, for Alexa, we design everything for every users. So we are not just building things for popular users, we're actually building things for every users. That's why I think that's the tenet we follow, even for the SaaS solution that we are building. And some of the things you will see as like all the personalization efforts, all these kind of things, reflecting the approach to say Alexa needs to be customized for every users and don't leave any user behind.
Correct. So what does it actually mean in practice? What does it mean to not leave a customer behind?
I think this in the practice on the SaaS, you will see the data sets like we're not just looking at, is this algorithm perform well for all the popular users. And for the users which is not using Alexa that frequent, or you have a different ways to using Alexa, we're also creating data set as a guardrail to make sure that we are not over-optimized for that.
Got it. So effectively, when you say an average user, right, I assume like an average user speaks in a certain way.
Yeah.
But some users might be speaking differently, might have a speech disability, for example. And you will want to have a data set which effectively allows that customer to still have a good experience with with Alexa.
Exactly. For the self-learning system that we build, the general ideas of that self-learning system is actually use majority of the users' ways to finding how to do the error correction to teach Alexa how to recover from users. But sometimes the correction only works for majority of the users, and there's small population of the users, like 10% of users, they actually don't like that correction. That's one example of the systems. And we explicitly build a system to identify these 10% of cases and reverse the correction. So they actually like the alternative result.
Wow, that's interesting, very interesting. So effectively, you are not only optimizing for the regular product P90, right? The 90% of the customers. You also look at the so-called tail, right? The 10% of the customers who have a very different need or very different way of interacting.
Exactly. That's how we make this correction very personalized, not leaving any users behind.
Got it. So recently, Alexa Plus launched in United Kingdom, the first European country with Alexa Plus. And from your team's perspective, what does it actually take to bring Alexa Plus into a new country? What are the biggest challenges from a language perspective or, culture perspective?
Yeah, I think there's many challenges I can talk about because my team built the runtime for Alexa.
Please tell us. We are interested.
So all these runtime services need to expand to the international locale. So it takes a lot of engineering effort for us to do it. And secondly, and if you think about cultural difference and the model you have for US may not be working for the UK because people were speaking thank you, other things in a different ways. We need to adjust the model a little bit. That becomes quite some of the learning for us for the future locale expansion.
Got it. So from that, maybe let's dissect that, right? So from that engineering perspective, is it just about, making sure that the latency is fine there, or is it, more complicated?
I think it's not just latency. When you move the service into a new locale, you need to make sure that's operation ready for that, and you don't want to have any incident to risking.
So reliability,
all these things needs to be there. That's the service part.
Got it.
But the other things is also about on the modeling part.
Right. And then, so how does it work? Do you need to teach that model, which corresponds to some of those utterances, different ways of interacting? Or would you rather create a new model, which is just designed for those different ways of interacting?
The easiest way is probably create a new model, but we probably would not do that because it's creating operation cost out of that.
Of course.
And also, like all these models, large language model, they are multilingual already.
Right.
And it's just sometimes they need a little bit tunings, fine tunings in order to adapt to certain kind of issue within the model.
Sure.
For example, we see grammar issue in certain locales. And we were getting the help from the local expert and creating the data for us to fine-tuning these models. And of course, for our model, the other levers people have is on the prompt. some of these defects you actually can solve through prompt engineering over there.
Got it. Yeah. And was there any particular challenge that you recall, or maybe somebody would not expect that this is challenging?
I mean, every day, if you see issues, it will be a new challenge. Okay. We will anticipate a lot of challenges on the way. But the good thing is when you go to one locales and you actually have a lot of learning, you know what you are expecting, and you're building pipelines or mechanisms in the places. So the next locale will be easier to go.
Got it. Yeah. So that's also an interesting, I would say, balance question, right? So effectively, as you're launching in that new country, right, locale, you're also trying to establish a process for launching in the next country, right?
Yeah.
There's some balance in between that, right? Like because that takes time and that takes energy, right? Versus you could probably launch earlier, quicker, right? If you would just focus on launching it at one country, right? How do you balance that as well?
And the strategy we have is not locale by locale. It's we want to launch for all. I think the mechanism we're basically saying is how to make sure we foresee the problem which we will see and was able to resolve at scale.
Got it.
So we do one models for all locales. That's where we share the learnings across. We want to have a fast speed.
So I assume you did apply those learnings for other country launches like Canada, Mexico, and I think your team was working on those models, right?
Yes, my team works on these models, and we work closely with the international teams and who help us collecting all these data and for allow my groups to fine-tuning the models so that we can overcome the issue that we're going to see over there.
Got it.
This allows us to go in parallel and reduce the time to release these models to the different locales.
Got it. So we did mention now Alexa Plus is on the web, like alexa.com, right? And then it's also on devices and expanding to new platforms. From a science perspective, what do you think is kind of the next frontier at this point?
I think Alexa, the voice assistant areas is still have a lot of unsolved problems. I think one of the problems that I will be seeing is how we are able to help user complete a very complex task.
Okay.
And how we can reasoning on top of the user things. And right now, Alexa is still doing quite simple things at this moment. And can Alexa do much more complex tasks from that? The second things I would say in the research area is speech-to-speech models. Instead of you are talking to Alexa turn by turn, meaning like how can we enable Alexa to become like human interaction? You actually can interrupt me, I can interrupt you as well. That's another areas. Of course, like how to spending time on multimodal related topic because you actually want Alexa to be able to have very complex input of the different modalities in order to reasoning on top of that. That's the third areas I would say we should take a look at that.
So when you say very complex tasks, can you give us an example of that, what you're thinking about?
So the complexity is relative. It doesn't mean that you have to say, Alexa, do A, B, C, D, E, F, G, and it's complex. Even I say, Alexa, help me plan a trip to Milan. And it could be complex because you don't know why I plan a trip to Milan and who we are. So how to resolving all these ambiguities and eventually have a conversation with user and help user to finish that complex task. And that's kind of like capability that we're looking for.
So this is interesting because right now customers do have that expectation of a single query or a single question resolving that entire or leading to a resolution of the entire task, right? But even when you have a human interaction, sometimes that human you work with needs to ask follow-up questions, right?
Yes.
So how are you thinking about that from an Alexa perspective? Like, is Alexa like allowed and eager to ask follow-up questions to such a question that you propose? For example, like plan a trip to Milan.
Yeah. I think Alexa should be. That's where we want to build Alexa to be able to we call it conversation facilitations,
Okay.
right? To have a good conversation with user and help user to finding their needs. It's very like human.
Yes.
When you and I was chatting, and sometimes the conversation starts without a purpose, but you help user to finding that purpose. And in the end, you accomplish something from that. I think I do hope the voice assistant eventually will go that path. And that will be truly a human-like voice assistant.
Right. And I assume then you could expand that, right? Also to visual cues, right? Like,
Exactly.
for example, shaking your head or doing a thumbs up, right? That should also be interpreted in some way in that conversation.
Correct.
And I assume that is only increasing the complexity for you, yes?
Not necessarily.
No?
I think really depends.
Why?
I think some of these things goes to the third bucket. You become multimodality kind of bucket. But
so you're able to interpret additional signals, but that doesn't necessarily increase complexity, yes?
Yeah, I think these days, and we also have models can take both as the input. So I think it does increase complexity, but also like this is the active research areas. I believe in like we will overcoming the difficulties from that.
I assume it does bring cultural complexity, right? Because not all the gestures mean the same thing in different cultures, yes?
You are right.
Yes.
And these are the things we're actually going to learn from expanding to different cultures, how we enable the capability across different locales.
So what would you say, to a young scientist perhaps pursuing a PhD, right? Like why that field, of speech AI or multimodal assistant, right? Like why is that an exciting field to pursue?
Because this field, we still have a lot of unsolved problems over there. And many of these problems, maybe you will only discover when you're working a large-scale voice assistant over here.
Got it.
And where these problems, you can discover these unique problems and contribute, make a contribution to these problems. And you can make a user impact if you make it to the production. And you can also influence the academic on that.
Got it.
So I think that's a very attractive areas for everyone to look into.
It's quite an interesting thing, right? That despite that field still being already very active, right? There's still so much things to explore, right?
Yeah.
And new capabilities to unlock, I think.
Yeah.
And I think customers are genuinely interested and eager to explore them. That's also super important, right? Because it helps to bring motivation, right?
Yeah, exactly.
Yeah.
I mean, if you ask me, I think some capability we see these days is super popular, like open cloud kind of things where I really hope like Alexa was able to help user complete a task autonomously.
Yes.
I think that's where probably one of the things we should really make Alexa to do.
That's the vision.
That's one of the vision.
Okay. How about we do a very close, quick lightning round of questions at the end of this conversation. So, what do you think is the most misunderstood thing about voice AI?
User may think like voice AI just speech recognition, but it's about conversation understanding. Understand the conversation, what user means.
Right. And replying so that the customer understands that we understood the conversation. Right?
Exactly.
Cool. One word to describe the Alexa Plus team.
Fearless.
Fearless. Okay.
We're fearless to be making success. We're fearless to fail.
Nice, nice. What do you ask Alexa most often?
To be honest, I'm a little boring, so I usually ask Alexa play some music for me.
Okay.
But I think that's also a good thing because Alexa is so personalized for me. So I don't have to give Alexa too many specific instructions, and it will personalize the music for me.
Right. What can't Alexa do yet? What you wish it could?
I wish it can help user complete a task without user even asking for it.
So completely proactive solution of tasks. Yes.
It will anticipate users' needs and was able to do what user want to do and have one step ahead of human.
Yes. And I assume it's becoming more complex as you're looking at, more forward-looking tasks, right?
Yes.
Perhaps anticipating what the customer might need in 5 minutes. it's one thing, but then understanding what they might need in a week, that's another thing, right?
Yeah.
So Edward, I wonder whether there was any particular customer story that, changed how you think about you build.
Yeah, I think this is a story where our CEO forwarded to all of us about Alexa, where one of our customer bought a Alexa device for his mom, and who is very old. And just one time, the mom fell on the ground and cannot call the ambulance. And he used Alexa to call the ambulance. And that saved his mom's life.
Yeah.
I think when we hear about that story, we feel we built something really save people's life, and it's getting super excited.
Yeah, that's truly a very powerful story, right? It's when we can help customers in such a way, I can imagine that's probably truly fulfilling for the team, right?
Correct.
Edward, thank you so much for this conversation. It was really great to have you here, and appreciate all your time.
Thank you for inviting me to this talk, and really happy to have a conversation.
Thank you so much.
Yeah.
So to everyone watching or listening, if you enjoyed this episode, follow us on YouTube, Spotify, Amazon Music, or Audible. New episodes of Amazon Stage explore the stories, people, and technologies shaping our future. Until next time, thank you.
Amazon Stage.